Hello, welcome to a lesson on kites. So kites, the definition we have here is a kite is a quadrilateral, four sides, with two sets of adjacent next to congruent sides. So I want you to notice in the diagrams below that there's always two sides that are congruent to one another. In our first diagram, we have that these two sides marked with one mark are congruent, and the two other sides, notice they're next to each other, sort of touching each other, right? They have a shared vertex right there. Then there's the two other sides that are double marked. They also touch each other or next to each other. They share a different vertex. I'm going to give you a vocabulary word for that in a second. Notice in all of our diagrams, the two sides that are adjacent, or excuse me, that are congruent to one another, marked with the same length, are next to each other or touching. We also have a special case here in the last one there that it's concave, right? This is a special category of a kite called a dart. So a dart is basically a kite. The two sides next to each other are adjacent, except that you have that inward pointing, right? You have the interior angle that's bigger than 180. It's a special case. Let's take a look at some vocabulary. So down here, we have a couple things going on. The diagram at the left here, the two angles that have vertices where the adjacent sides are congruent on the left and the right. Notice the two sides that are like matched there, and on the right hand side, the two sides that are congruent have the shared vertex there. Those are called vertex angles. All right. The other ones are called non-vertex angles. Just vocabulary, no big deal there. Also, there's some really cool properties if you look at the diagonals here in this picture. I know we've studied diagonals in previous lessons. If you construct the diagonals of a kite, a couple of cool things happen. First of all, they're obviously not equal in length. Notice it looks like a traditional kite, but they bisect at one another. One of them bisects the other one. Can you tell which one it is? It's probably fairly obvious in that the segment KT in this diagram is bisected by the other, by in this case, the longer of the two diagonals. And also they cross at a 90-degree angle. Let's look at that with GeoGebra. I'm also going to share with you how to construct it. Pardon me. So what I did here is I constructed two segments that have a common endpoint. You can construct sides that are equal in length by using your circle with center tool. So if I click on A and carry it over to B, I have a circle there. Okay, I can put a point somewhere on that. Anywhere I put a point on that, what you'll notice is it's the same radius. So what happens is that that new segment AD is equivalent in length to AB. See how they match? The problem is, where do I put it? So let's go back for a second. I'm going to take that point away. Then you go back and use your circle with center tool on the other endpoint, which is C. So start at C and drag over to B and click. What you'll notice is those two circles intersect at a given point there. So I'm going to click more. Remember, you have to click more twice to get to the intersect tool. And I'm going to look at the intersection where they cross one another right there. So what you should notice is that you can now make a polygon A, B, C, D, and back to A, and we have a beautiful kite right there. Now, if you to turn off the circles, you could play with this a little bit, and you can play with the diagonals. Okay, you can make your dart right there, right? You can make a skinny dart. You can make all different kinds of kites, and so those are fun to play with. So I would encourage you to do that, construct the diagonals, and ensure that they're always perpendicular. And I'm just going to show you that briefly before we go. If you connect A to C, and B to D, you can really tell that those look to be perpendicular, and you can play with the tools to verify that no matter how you don't do that, that how you have this kite that's not a dart, you have that perpendicular.